So now this video discusses about the quadratic expressions, where we'll be talking about the basis of the quadratic expressions, components of the quadratic expressions, and also how we can be able to factorize the quadratic expressions. So keep that in mind. So what is the basis of the quadratic expressions? Now you should have to understand that we have two or more types of the expressions. We have what we call as the monomial expression. So if we say a monomial expression, this is the expression made up of only a term. That is a monomial expression. So it is an expression that is made up of only single a term. For example, if we have 2x, this is the monomial expression. If we have, let's say, 5, this is the monomial expression. If we have, let's say, a 6y, this is a monomial expression. Let's say if we can have 1 over, let's say, 2x, this is also part of the monomial expression. So try to give out more examples of the monomial expressions that you can have. And we also have another type of the expression, which is a binomial expression. So what do you think a binomial expression is? Now, as the name itself suggests, bi means two. Now, on the binomial expressions, now these are the expressions with the two terms. These are the expressions made up of two terms. We can have, let's say, 2x plus 1. This is the binomial expression. We can have, let's say, 6x plus 2. This is also the binomial expression. Let's say negative x minus 1. We can have, let's say, negative 2x plus, let's say, 5. All these are the examples of the binomial expressions. Let's say 5m minus, let's say, 6y can be that. And let's say if we have negative 2, let's say q minus k. All these are said to be the binomial expressions. And we also have what we call as trinomial expressions. So trinomial expressions. So what is the trinomial expressions? Now if we say trinomial expressions, these are the expressions that are made up of what we call as three terms. That is what we call as the trinomial expressions. So these are the expressions made up of three terms. And what is the basis of the trinomial expressions? So trinomial expressions are formed from the what we call as binomial squares. So what is the binomial square? What is the binomial square? Now if we say binomial square, this is the square of the binomial expression. That is what we call as the binomial square. So it is the square of the binomial expressions. And let's say we have x plus 2. This is the binomial expression. And what is the square of the binomial expression? That is what we call as the binomial square. And let's think of expanding what is this one. So in this case, this is the same as x plus 2, times x plus 2. Then if we further expand this, we'll have it as x times x, that is x squared. And x times 2, that is 2x. And 2 plus times x, that is 2x. And the 2 times 2, which is given as 4. So in this case, we'll have it as x squared. And these are like terms. We'll have it as 4x plus 4. Now this is what we call it as a trinomial. Should be trinomial expression, which is formed from the binomial square. So this is what we call it as the trinomial expression. And let's have to come up with different examples of the binomial squares. We can have, let's say, 2x minus 5 to the power 2. That will be given as, in this case, we'll have it as 2x minus 5 times, we'll have 2x minus 5. In this case, this is the same as 2x times 2x, that is a 4x squared. And the 2x times negative 5, that is negative 10x. And negative 5 times 2x, that is negative 10x, and a plus 25. So in this case, we'll have it as 4x squared. minus 20x, plus 25. This is what we call as trinomial expression. And try to come up with the trinomial expressions for the following as well. What if we have, let's say, m over, let's say, 5 minus 2, and let's say times m over, let's say, 6 plus, let's say, 7 in this case. Now, how should you have the trinomial expression for this? So in this case, we'll have m over 5 times m over 6, which is the same as m squared over 30, like that. And m over 5 times 7, that is given as positive 7m over 5. Then 2 times actually m over 6, which is the same as negative 2m over should be 6. And negative 2 times positive 4, actually 7, which is negative 14 in this case. Now these are the like terms, we should have to add them. So in this case, let's have 7m over should be 5 minus, by then in this case we can have 2 into 6, which is 3. We'll have it as m over should be 3. We should add the two fractions, that will be given as, so in this case we'll have it as it should be 21m minus 5m, which is divided by should be 15. So in this case we'll have it as, that should be given as 16m divided by 15. So that is the summation of the fractions. So 16m divided by 15. So in that case we'll have it as m squared divided by 30 plus 16m divided by 15 and the minus 14. So this is what we call as trinomial expression. And try to come up with the following, actually try to come up with the trinomial expressions for the following actually binomial squares. Let's say if we have m plus 2 to the power 2, that is, and let's say we should have, let's say, n minus 5, and that should be that. Let's try to have that one out. And let's say if we can have, should be 4x minus, let's say, 6, try to have that one. And let's say if we can have, let's say, a 6x minus 7m, try that one. So try to come up with the binomial expressions, should be trinomial expressions from those actually binomial squares. So now, what is the quadratic expression? What is the quadratic expression? Quadratic expression, is the same as actually a trinomial expression, in the sense that, let's say we have the binomial square which is given as x plus 2. In this case, if we expand this, we'll have it as x plus 2 times x plus 2, which is the same as x squared plus 2x plus 2x, and that plus, let's say, should be 4. This is the same as x squared plus 4x, and that plus 4. Now this is what we call as the quadratic expression. In other words, a quadratic expression is the same as a trinomial expression. Keep that in mind. In this case, the quadratic expression follows the order of ax squared plus bx plus c. So this is what we call as the quadratic expression, where the first part is given as, it is said to be a quadratic part. It is said to be a quadratic part. And the second part is given as the linear part. It's said to be a linear part. And the other part is said to be constant part. So those are the actually parts of the quadratic expression, where actually a, b, as well as the c, those are the constants. So let's try to come up with examples of the quadratic expressions that we can decide. We can have, let's say, 2x squared plus 7x minus 2. So in this case, the value of a is given as should be 2, and the value of b is given as 7, the value of c is given as negative should be 2. And how about, let's say, if we have negative x squared minus x, let's say minus 2. So in this case, the value of a is given as the negative 1, and the value of b is given as the negative 1, the value of c is given as the negative 2. So keep that in mind. And how about, let's say, if we can have this, let's say we have m squared minus 7m plus, let's say, half. So in this case, the value of a is given as 1, the value of b is given as negative 7, and the value of c is given as half. So by the way, this is how you should have to denote, the constants on the quadratic expression. And let's say if we have, y squared minus 7y. So in this case, it's true more, this is the quadratic expression, only that the component which is missing, it is the constant part that we can include it as L. So in this case, we have a being given as 1, and the b is given as negative 7, and the value of c is given as L. So the part which is missing, include that one as L. And how about, let's say, if we can have, should be, let's say, 2z squared minus 4. Now how should we have this? Now from the fact that it is having the highest degree power given as 2, this is quadratic expression, where a is given as, so the part which is missing, it is the middle part, which is the linear part. So we should have to include that as L. We'll have 2z squared, plus 0z and the minus 4. So in this case, a is given as 2, and the b is given as L, and the c is given as negative 4. So keep that in mind. And we can also have, let's say, if we have something about, 1 over 3, and that should be q squared minus, let's say, 1 over 2. It should be 1 over 21. So it's true more, this is the quadratic expression. The component which is missing, it is the middle acted part, which is a linear part. We have 1 over 3 q squared, and the one missing, we'll include that as L, 1 over 21. So in this case, we have a which is given as 1 over 3, we have b which is given as L, and c is given as the negative, it should be 1 over 21. So keep that in mind. And let's say we have the binomial square given us, should be x minus 5. So in this case, so we should have to deduce the value of a, value of b, and also the value of c in that case. So how should you have it? So first thing, we should have to expand. We'll have x minus 5, times x minus 5 as well. If we properly expand, we'll have it as x squared minus 10x plus 25. So in this case, the value of a is given as 1, and the value of b is given as the negative 10, and the value of c is given as 25. That is, how about if we have, let's say, 1 over y plus, let's say, 2 square. So what is the value, what are the values of x? Actually, what are the values of a, b, as well as the c? So in this case, this is the same as having it as 1 over 2y, and plus 2 times, 1 over 2y plus 2 in this case. So this is the same as having it as, this is the same as having it as y squared over 4, and should be plus y, and plus y as well, and plus 4. Because if we have, 1 over 2 times y, 1 over 2 times y, this is the same as this. Likewise, 1 over 2y and times 2 will have it as, that y, because this 2 and this 2 will have to cancel, so have that and as that. So still you have something like that. So these are the like terms where I'll have it as, y squared over 4 plus, it should be 2y plus 4. So now in this case we have, the value of the a, which is 1 over 4. Bear in mind that if we have, let's say, m over a, this is the same as having it as m times 1 over a. It is the same as that. And in all cases, it is the same as that. In all cases, it is the same as that. Likewise, if we have, let's say, x times y, over n. You know this is the same as x times y over n, and also this is the same as, you know, yx over n. It is the same as that. That is how you should have to get that one up. Now in this case we have it as the coefficient of actually y square, which is given as 1 over 4, and the value of b is given as 2, and the value of c is given as 4. That is positive 4. And also try to determine the values of the constants and in each of the actually following given binomial squares. Let's say if we have the first case, which is given as 2 minus m to the power 2, we should have that. And if we have 2x minus 10, we should have the values of the constants, that is a, b, as well as the c. And let's say we should also have, you know, y minus 5 to the power 2, and we should also have, let's say, z minus 2 should be that. You should have to deduce all those things. So try to have that one. So now, how can we be able to factorize, you know, the quadratic expression? So we should have to understand that, you know, let's think of having binomial square given as x plus 2 to the power 2. You know, this is the same as having it as x plus 2 and it times x plus 2. You know, that would be given as x squared plus 4x and plus, let's say, 4. Now, if we are to factorize the quadratic expression, the essence behind this is that we should have to, the essence behind is to express the quadratic, actually it is to express the quadratic expression from this form and back to this form. That is, we should have to express the, always it is, you know, always you have been given the quadratic expression, that is, you are to express it back to the actually binomial expressions like those. That's the principle behind. Let's say if we have the quadratic expression, which is given as x squared, let's say, plus x minus 6. So how do you think we can have to factorize actually this quadratic expression if that is the case? So all we need is that we should have to express this one to be the product of two actually binomial expressions. That is the principle behind. So whenever we are to factorize this particular actually quadratic expression, these are the things that we should have to consider. So first thing, we should have to compare the given expression with the general form of the expression, which is given as ax squared, you know, plus bx plus c. So in this case, this expression, you know, this given expression resembles the general expression of the quadratic. Then we should have to identify what is the value of the constant a, that is given as 1. And what is the b is given as 1 as well. And what is the c, we have it as negative 6. Then from there, we should have to have the product of a as well as the c. So we should have to multiply a times c, which is the same as 1 times negative 6. So in that case, we have it as negative 6. Then let's think of having the pairs of the factors of negative 6, that when we add it will give us positive 1, but when we multiply it will give us negative 6. So what are those? Now, negative 6 is the same as negative 1 times 6. It is also the same as negative 6 times 1. It is also the same as negative 3 times positive 2. It should be like that. And also it is the same as negative 2 times positive 3. So these are the actually possible pairs for negative 6, that when you multiply will give us negative 6. Now on these pairs, let's think of having the pair that when we add will give us, should be positive 1. So with your calculator, try to have that one. So in this case, you know, negative 1 plus 6, this is the same as, should be positive 5. So this can't be the pair. This can't be the pair. In negative 6 plus 1, it is the same as, should be negative 5. This can't be the pair. Negative 3 plus 2, it is the same as, it should be negative 1. This can't be the pair. But negative 2 plus 3, it is the same as the positive 1. So this is the best pair to choose. Now, if this is the best pair to choose, then you should have to present it as this. So if this is the best pair to choose, then you should have to express actually negative 6 as, now have negative 6n, should be negative 6x, which is the same as that of negative 2x plus 3x. So that will be given as that. By the way, you should have this. Sorry for that. Now, if this is the best pair, which is given as negative 2 plus 3, then we should have to express the middle part, which is x, is the same as negative 2x plus 3x. It is the same as that. Therefore, we'll have to substitute for x with that one. So in this case, what will go up next? We'll have it as now x squared minus 2x plus 3x minus 6. Then now we'll have to pair up these and also pair up these. So in this case, what is the common factor here? We have it as x. We'll have x minus 2. And what is the common factor here? We have it as a positive 2, positive 3. We'll have 3, that will be given as x minus 2. So in this case, since this and this is the same, we just have to choose one. We'll have x minus 2 and the times combination of the outer actual terms, that is x plus 3. So this is how we factorize it. And also, let's appreciate how we can have this. Let's say if we have x squared plus, let's say, 7x, and should be minus 7x, not plus. We should have it as minus 7x and plus 10. So how do you think we should have to factorize this one? So first thing, we should have to identify what is the value of a, which is given as 1, and what is b, which is given as should be negative 7, and what is the c? We have it as should be 10. Then let's have the product of a as well as the c. We have a times c, which is the same as 1 times 10, which is given as a positive 10. Then let's think of having the pair of factors of a positive 10, that when we add it will give us negative 7, but when we multiply it will give us positive, should be 10. So let's think of highlighting the possible pair of the factors. So we have 1 times 10, it is the same as that, which is given as the 10. And we also have negative 1 times negative 10, that is also the possible pair. We have 2 times 5, that is also the possible pair. Negative 2 times negative 5. So now, out of these actual pairs, let's think of having the pair that when we add will give us, that should be negative 7. So 1 plus 10, that is given as 11. This can't be the pair. And also this can't be the pair as well. And also this one can't be the pair because this is positive 7. But the best pair is given as negative 7, which is given as this. So which means this is the pair we should have to choose. If that is the case, it means we have negative 7x, it is the same as negative 2, negative 5. So we should have to, by the way, we should have to express in terms of x as well. So which means negative 7x, it is the same as negative 2x, negative 5x. It is the same as that. It means we'll substitute here for that one. So sometimes these pairs can be, you can do these, actually you can find these pairs, somewhere, then on your answer you just have to present this. It is okay as well. So in this case we have x squared minus 2x minus 5x plus 10. We'll have that. Then we'll have to pair up these like that. So in this case we have, what is the common factor here? So we have it as x minus 2. How about the common factor here? Now the common factor is given as negative 5. So which is given as negative 5 into negative 5x. We'll have it as, positive x. Negative 5 into positive 10, that is negative 10, actually negative 2. And make sure that what we have here should be the same as what you have here. So since these are the same, then we'll have to pick one and times the combination of the out ones, that is x minus 5. So this is how we factorize that one. How about if we have the following cases as well? Let's say if we can have, and that should be x squared, and let's say plus 8x, let's say plus 12. How should you have to factorize this one? Principle remains the same. What is the value of a? We have it as 1. And what is the value of b? We have it as 8. And what is the value of c? We have it as 12. Then what is the a times c? We have it as 12. So let's think of having the pairs of, factors of 12 that when we multiply will give us positive 12. But when we add, it will give us positive 8. So in that case, what is the actually very possible pair? You should have to decide. So the very possible pair, it is that of 2 times 6. This is the very possible pair. Hence we have 8x is the same as 2x plus 6x. Then we have to substitute this for it. So what will be that? So in this case we'll have it as x squared plus 2x plus 6x plus should be 12. Then we just have to pair up this. So what is the common factor there? We have x plus 2, and the plus we have 6x plus 2. So in this case we'll have x plus 2 times x plus 6. So this is how we should have to factorize that one. So sometimes you can go just for the direct pair of the factors without even thinking of some sort of trial and error thing. Let's say if we have m to the power 2 and that plus 2y should be 2m, rather should be 2m, and let's say minus 35. So how do you think we should have this? So principle remains the same. What is the value of a? We have it as 1. And what is the value of b? We have it as 2. And what is the value of c? We have it as negative 35. Then we should have a times c, which is the same as negative 35. Let's think of having the pairs of the factors that when we multiply will give us negative 35, but when we add will give us positives, actually positive 2, which is the value of b. So what is the very possible pair we should have to decide? So the very possible pair, it should be given as, that is negative 5, times 7. Because if we have the sum of this, will give us the positive 2. But if we multiply, will give us negative 35. So which means 2m, it is the same as negative 5m plus 7m. We should have that. Then we'll have to substitute this for 2m. That will be given as, m squared minus 5m plus 7m and minus 35. Then we should have to pair up this. So what is the common factor there? We have m and m minus 5. And then we have positive 7, which is m minus should be 5. So in this case, this is the same as m minus 5, times m plus 7, like that. So that's the principle behind. And let's say if we can have something like this, then we should see how we can make it up like that. And I try to have the following on your own times as well. Let's say if we have x squared, and let's say minus x, and that should be minus 20. How do you have to factorize that one? And also try this one as well. Let's say if we have x squared, let's say minus let's say 3x, and that should be minus 10. How do you have to factorize that one? And let's say if we have x squared, and let's say minus 9x plus 40, and let's say if we have, and that should be x squared, and minus 10x plus 24. And how about if we can have, let's say x squared, let's say minus 8x, that is plus 15. How do you think we should have to factorize that one? And I try to go through such kind of the cases. Now sometimes you can have something that seems to be complicated. Let's say if we have, a 6x squared plus, let's say 3x, should be 13 rather. We should have 13x, and let's say plus 6. Now how do you think we should have to factorize this one? Now this is something different because actually the value of a is no longer 1. It is something other than 1. So in this case a is given as 6, and the b is given as, it should be 13, and the c is given as positive 6. But principle remains the same. We'll have the product of a as well as the c, which is given as 36. Then let's think of the pairs of the factors of 36, that when we add will give us the positive 13, but when we multiply will give us positive 36. So what do you think is the pair? So in this case we'll have 4 terms, should be 9. If we have the summation of this one, will give us the positive 13, but if we multiply those, will give us, should be positive 36. So in this case it means 13x is the same as 4x plus 9x. It means we'll have 6x squared plus 4x plus 9x plus 6. So we'll have to pair up this. What is the common factor? We have it as 2x, that is 3x plus, it should be 2. How about there we have it as positive 3, which is 3x plus 2. So in this case we have 3x plus 2 and it times 2x plus 3. So that's how you should have to factorize that one. Now how do you think if this is the case? Let's say if we can have something about, let's say if we have 4x, should be 4n squared, and let's say plus 20n, let's say plus 21. How should you have to factorize this one? Principle remains the same. What is the value of a? We have it as, should be positive 4. And what is the b? We have it as positive 20. And what is the c? We have it as the positive 21. So we should have the product of a as well as the c, which is 4 times c, which is 4 times 21, which is 84. And think of the pairs of the factors of 84, that when we multiply will give us 84, but when we add will give us, should be positive 20. So the easiest way to go for it is, sometimes given these kind of the big numbers, it is also helpful to use this technique. That is, we have it as 84 here. Then what is the lowest common factor? We have it as, let's say, 2. What is 2 into 84? Which is given as 42. The 2 into 42, that is given as, should be 21, and we should have, let's say, 7 to 23. Let's think of using 3 into 21, that is given as 7, and 7 into 7 we have it as 1. So we should have to choose the pair of those factors using these update factors. So let's think of playing around with these factors. So we can decide that we should have 4 times 21. So we have 4 times 21. Then we also have, we should have 4 times 21. It is also possible. And we can also have, 2 times c. Let's say 2 times c. What is multiplication of 2? 2 times c, that is, we can have 42. That is also possible. What is another possible pair? We can have, let's say, 7 times c. Should be 7 times c. We can have 7 times c. Now in this case we have 2 times 2, that is 4, and 4 times c, 3, which is 12. So we can have 7 times should be 12. That is also possible as well. That we can use should be 7 times 12. That is another possible pair. 7 times 12. How about another pair so we can have? Let's think of having, let's say, 3 times. Now in this case we have 4 times 7, which is 4 times 7, which is 28. And another pair we can have, it is 14 times 6. So let's think of choosing which pair is the best to suit according to our needs. So if we have the summation of positive 4 times 21, that is given as 25. This can't be the pair. And how about this? If we sum those, actually if we have the summation of this one, will give us, should be something about 44. So this can't be the pair. How about 7 plus 12? It will give us the 19. This can't be the pair. How about this one? It will give us 31. This can't be the pair. How about this one? This one will give us, should be something about 20. So this is the pair to choose. So which means if that is the case, it means having 20n, it is the same as having 14n plus 6n. So this is what I need to substitute with at this point. So from there you can be able to, from there you can be able to have it as, 14n squared plus 14n plus 6n plus 21. So in this case we'll have to pair up this and also pair up this. So what is the common factor here? We have it as 2n, which is 2n plus 7, like that. And how about here we have it as positive, should be 3, which is 2n plus 7, like that. So we have the same things here. So just have to pick one and it times 2n plus 3. So that is how we should have to factorize that one. And also think about this one as well and appreciate how we can be able to make it up. Let's say if we have, should be 12x squared and minus, let's say, 4x, and that should be minus 5. So how do you think we should have to factorize this? So principle remains the same. What is the a? We have it as 12, and what is the b? We have it as negative 4, and what is the c? We have it as negative 5. We should have the product of a as well as the c. So positive 12 times negative 5. So times negative 5, that is negative 60. Then let's think of having the pairs of, pairs of negative 60. That when you multiply will give us negative 60, but when you add will give us negative 4x. That is negative 4. So since this is actually, since this seems to be a very big number, so the easiest thing is to use the same principle. That is 60. So 2 into 60 we have it as, that is 30. The 2 into 30, that is 15. We should have 3, that is 5. 5 into 5 is given as 1. Let's have the mixture of these numbers and see how we can make it up. So the first two, actually the first 2 that is given as 4, now we can have negative 4 times c should be positive 15. We can have that, and we can also have negative 15 times positive 4. We can also have, let's say, negative 2 times, times 30, positive 30. Negative 30 times positive 2, can have that. And we can also have negative 5 times, should be positive 12. We can also have negative 12 times, it should be positive 5. That is also possible as well. And how should we have to proceed further? We can also have another pair. We can also have something about, let's say, 3 times negative, that is 3 times negative 20, and also let's say negative 20 should be negative 3 times 20. Let's say negative 3 times positive 20. So let's choose the best pair that when we add will give us should be negative 4. So what do you think is the best pair we can choose there? So what do you think is the best pair we can choose from that point? So in this case, if we have the summation of those, that is negative 4 plus 2, actually plus 15. Negative 4 plus 15, that is automatically given us, and should be 11, like that. And how about if you can have this one, should positive 11, this one will give us the negative 11. So can't be this pair and it can't be this pair as well. And we also have another pair which is given us 10 times negative 6, and actually negative 10 times positive 6. And without wasting much of our time, this is the best pair to choose, that is negative 10 times positive 6. So which means negative 4x is the same as the negative 10x plus 6x. So try to have that one. So try the following questions at your own time as well, and appreciate how you can have them. Factorize, let's say 6c square and plus 23c and plus 15. And also try this, that is 15a square and let's say plus 2a minus 1, and we should have, let's say, 6x square and plus 5x, and that is minus 6, and we should also have 9b square minus, and that should be something about minus 21b, and let's say minus 18 should be minus 8. Let's say we also have this case, let's say 4ym square should be 4m square, and then minus 4m, and that should be minus 3. And let's say we should have the following, let's say 3a square, and that is plus 7a minus c, and that should be 6. So try to factorize this. Thank you.